Okay, welcome back from the coffee break. Our next speaker is Satyajit Sahoo. Sorry, Satya, I messed that up. He works at Callstack, based out of Wrocław. They do React Native Europe, which is another React Native conference in Poland. He has contributed for years now to the React Native community. He's made libraries like React Native Tab View, works on React Native Paper. Pretty much, he has fingers everywhere. He works on React Navigation with me. Worked on Snack. You probably all use Snack. He is responsible for a lot of that stuff. And now he's just going to talk about some advice for building a UI library. And he's really kind of the perfect person to talk about this. So, yeah.
Thank you, Brent. Hello, everyone. Dzień dobry, Kraków. I'm very excited to be here today talking about building component libraries for React Native apps. My name is Satyajit Sahoo. I work at Callstack. I also contribute to React Native Paper and React Navigation. And you can follow me on Twitter at Satya164. OK. So when I say component library, what I mean is a collection of components. For example, you have heard of Material UI library, right? It's a collection of multiple components. Building component libraries is very different from building an app. Why? Because when you're building an app, you know what your use case is. You know the constraints. You can hardcode things. But when you're building a library, you have to keep things more generic. You have to be more flexible because you don't know how people will use your library, right? So today, I'll be talking about my experience in building component libraries and the challenges involved. So some of the challenges are cross-platform accessibility, documentation, tooling like testing, code quality, and many more. So let's dive into it. So cross-platform. A promise of React Native is cross-platform development. A lot of people come to React Native because they can use the same code on iOS and Android, and now web. So because cross-platform is very important for React Native, we need to handle a lot of things when we are building a component library to handle cross-platform things. Because there are differences. Like on Android and iOS, there are differences between the design. But there are also differences between the APIs and what kind of features they support. So when we are writing that code, we have to handle it manually. We have to have workarounds or platform-specific conditions. So I will cover some of the differences in the next slides. So I think the biggest one is overflow. On Android, the overflow area is hidden. And on iOS, it's visible by default. In recent versions of React Native, you can actually set it to visible on Android. But say your component is here, and this is overflow area, and you have some touchable or gestures in this area. On Android, it's not possible to interact with this. So you cannot really use it all the time. So I think the best way to address it is always assume that overflow is hidden by default and design according to that. Because that's the minimum thing you can build, right? OK, so the next thing is text background. This is a very small thing. And many of you might not have noticed it at all. On Android, the background of text is transparent. But on iOS, there is an opaque background. You'll see it when you have text over an image or a gradient color. So it's very easy to fix. You just have to set background color to transparent. but it's disabled by default because it improves the performance on iOS. So the next one is touchable. You might know that on Android, when you touch a button, there is a ripple effect. And on iOS, there is a fade effect. The opacity changes. React Native provides different components to have this behavior. For Android, there is touchable native feedback. And for iOS, there is touchable opacity. Unfortunately, there is no single component to have this, so you always have to write if platform OS Android use touchable native feedback, otherwise touchable opacity. But even that condition is not enough, because touchable native feedback with ripple is only supported on Android 5 onwards. If you try to use it on older Android versions, your code will crash. So you can use this library, React Native Platform Touchable. It's made by our lauded savior, Brent Watney. It renders a touchable native feedback on supported Android versions and touchable opacity on all other versions, like web or iOS. In React Native Paper, we also have a custom touchable component, which renders a ripple effect on Android and a highlight effect on iOS. But we also have a separate component for web, where we render it, where we render a ripple effect. And the next one is elevation and shadows. On Android, there is no shadow property. There is a single elevation property, which maps to the elevation property on the native side. So it's very different from shadow. On iOS and web, you can control the color, how big the shadow is, what's the opacity, and all these things. But with elevation, you cannot control anything. You have a number, and there is a predefined shadow which will be rendered. So elevation is like a Z index. It's the position of the item on the Z axis. So the higher the item is, the bigger is shadow. That's all you get. You increase the elevation to get a bigger shadow. So this is one difference you need to handle when designing things. What I like to do is I have a shadow function which takes elevation and returns a cross-platform style for all of the platforms. This is a very rough implementation. This doesn't actually has an accurate style on all platforms. But in React Native Paper, you can check the code base, where we have a very more complex implementation. It handles animated values, and it also has accurate shadows across all the platforms. OK, so the next one. This is my favorite, most exciting part. Notches, right? So this is very complicated to handle in a library. For example, there is this height. It can be a notch on iPhone 10. It can be the status bar height on older iPhones. Also, on iOS 11 and above, there is safe area view in React Native that you can use to handle this. But it doesn't work if you're below iOS 11. So it doesn't work on iOS 10. And it doesn't work on Android. So yeah, so what do you do? And even on Android, there are two cases. You can have a translucent status bar, in which case your app renders under the status bar. So you have to add a padding on the top. But you can also have an opaque status bar, in which case you don't need to handle it. And there is no API to detect it. So you never know what condition your library will render in. You cannot handle it automatically. We have this logic in paper, where we try to guess what the status bar height is. For example, we detect if it is Expo. If you are running in Expo, Expo has a translucent status bar by default. So we always assume that there is space above to handle. And if you are on iOS 11, we use safe area view. That's why we have 0 here. And otherwise, we use our hard-coded value. But there is this pull request in React Native repo called layout context. This API is cross-platform, works on all of the Android and iOS versions. And you can get the height of the safe area at the top, also the height of the navigation bar at the bottom. So, but it's not merged yet, so it will probably take some time to get merged. But look forward to better handling of status bar very soon, I hope. OK. So we talked about how you have to have conditional styles and conditional code between platforms to handle some things, right? So there are several ways to do it. One of the ways is to have this extension. You can have .android.js, .ios.js. There is also .native.js, which applies to both Android and iOS. Or you can use index.js. How Metro works, Metro is the bundler for React Native. It checks for the most specific thing by default, like say you are bundling for Android. So it will check index.android.js. If it doesn't exist, it will check for .native.js. And if that doesn't exist, it will check for index.js. So you can take advantage of this to provide fallbacks. Say, for example, in your component library, you support only Android, right? So you can create another .ios.js file which renders an error message or something when somebody tries to use it in their app, right? Or you can also have a index.js, which is what will be used on web. Or say you only want to support web. You cannot support native. So you create two files, index.js and index.native.js. So the native.js will be used on both iOS and Android, and index.js will be used on web. So this is one way of handling. And when building for cross-platform, it's important that you have a fallback. Why? Because if you don't have a fallback and somebody tries to use it on that platform, bundling will fail. They won't be able to import it at all. For example, say you have a component library, 9 out of 10 components support all of the platforms. There is only one component which only works on iOS. Now, if you don't provide a fallback, the user cannot use it on any platform. So it's better to have a fallback. OK, another way is to use platform select API. You can provide keys like iOS, Android, and you can also provide a default key for fallbacks. OK, so we talked about so many platforms, right? There are also Windows, tvOS, macOS, and many more. But all we want, I know, is React Native for Samsung Smart Fridge. How awesome it will be like to browse your app on a smart fridge. It will be awesome, right? But actually, that library already exists. There is React Native Tizen.net, which works on Samsung Smart Fridge, because it runs on Tizen. OK. Responsive design. You might be thinking, what is responsive design on mobile? It's a big thing on web. We all talk about building responsive websites, right? But I think nobody talks about responsive design on mobile apps. But it's very important. Many apps I see, they lock their orientation to portrait. And you rotate your phone or try to use it on a tablet, and it doesn't work properly because it's locked to portrait. That's one reason why your app should be responsive. But that's not the only thing. There are more things, like split screen mode. On recent versions of Android, you can have multiple apps in the same screen. On tablets, it can be side by side. On phones, it can be top and bottom. There is also a free-form window mode. It's basically like desktop apps. This is for bigger tablets, Chromebooks, etc. You can drag windows to resize, just like desktop apps. You have to enable this explicitly, but it's there. So it's another thing which needs to be responsive. But right now, it's not very easy to build responsive layout in React Native. On web, we have media queries, but in React Native, we don't have anything. We have a dimensions API, which we can use to get the root dimensions. But it's not good because it's a constant. You get it once, then you have to manually listen to changes and update it. Right? It's not good. But so my recommendation is do not use the dimensions API. It's very difficult to use. And another big issue with dimensions API is components are supposed to be self-contained, right? When you are building a component, you should only worry about where it is rendered. But dimensions is for the whole screen. So if you're building a component library, you don't know if your component will be full screen. The user can render it in a sidebar or somewhere, right? So don't use it. Use Flexbox if it is possible to use Flexbox. But sometimes you do need layout. So there is this onLayout API in React Native, which gives you the layout whenever it changes. But there is one caveat with that. It's asynchronous. So before you have onLayout, there will be your app rendered already. Then onLayout will be fired. Then it will re-render again. So you'll see a flash. So you have to do some trickery to handle it. I had this issue in a library I built, React Native tab view. So how I handle it is I have this, say you have 3 screens in a tab, right? So what I do, I don't render all of the 3 screens because I need the width of the screen to render those. So I only render one. I put it absolute fill, so it fills the whole screen. Then when I have onLayout, I can now render 3 screens, each with the width of the screen. So it's a bit hacky, but it works. This is an example of how it looks. You can see it renders properly. It reacts to orientation changes and everything. OK, accessibility. Ankita already talked about this in detail before me. But I don't have a lot to talk about because my talk is more generic. So what exactly is accessibility? There are a lot of different kinds of disabilities that we need to handle. But accessibility is not only about disabilities. Accessibility is about being inclusive. Everyone should have the same opportunity, right? Just because someone speaks a different language, or just because someone cannot see properly, they should not have a bad experience with your app, right? So when you're building a component library, it's very important to have accessibility baked in, because that component library is a building block, and it will be used in many different apps. And if that building block does not have accessibility, it's very difficult to implement inside apps, right? So let's talk about what kind of accessibility features we need to worry about. And I will just quickly glance through how we test it and stuff like that. So first thing is visual impairments. There are blind people who cannot see anything. There are low-level vision, they cannot see properly. And then also there is color blindness. They can see, but they cannot see the colors properly. They can see some colors, but not others. So we need to address for that. Then there is hearing impairments. People who cannot hear or have very low hearing capabilities. There is language disorders. People who have trouble understanding grammar, right? And this is something we need to handle. Then there is mobility impairments. People who have very limited ability to move. It can be due to physical issues, like maybe you broke your leg or broke your hand or something. Or it can be genetic or neurological disorder. So, there are so many issues we need to address, but I will just cover screen readers in my talk because that's the part we are encountering the most in our apps. Unless you have video, you don't need to worry about hearing disabilities, right? So screen readers is the most important part. So there are several tools on Android, iOS, Mac, built-in tools which allow the user to interact with an app via accessibility tools. There is a TalkBack app on Android. There is a VoiceOver on iOS and Mac, Narrator on Windows, Orca on Linux, Chrome Vox on Chrome OS. But these are just the built-ins. There are also commercial and free screen readers like JAWS, and there are many more. So how they work? You already saw a video before. So they read what is on the screen, and you can double tap or double swipe. There are different gestures to interact with the elements on the screen. So we need to make sure that we properly announce the elements on the screen, and the user is able to interact with them properly. So to test these screen readers, I think the best way is to just test them, like test on actual device, test with a screen reader, and see that you can interact with the app. But on iOS Simulator, there is no such thing. You cannot use VoiceOver with iOS Simulator, so you have to use Accessibility Inspector. But on all other platforms and iOS devices, you can use the inbuilt screen reader. This is a screenshot of Accessibility Inspector. As you can see, it tells you what the label of the button is. And you can also click there to perform the accessibility gesture. And you can see that if it works. So there are many things missing right now. And we cannot implement everything right now because a lot of APIs in React Native are missing. Right now, there is accessibility role, accessibility states. You can implement buttons using accessibility role, but you cannot say that this is a switch or this is a checkbox. These APIs are not available. So we cannot do much, but let's at least try our best, right? And if somebody wants to send a pull request to React Native, adding these features, you are my hero. OK, so what else? When we are building for accessibility features, we should make sure that we use the semantic elements. We should use the elements which are already available. For example, there is a switch component in React Native. We should just use it instead of implementing our own switch. Because that switch element has proper accessibility role, proper behavior for accessibility tools. And if we try to implement it ourselves, we have to re-implement all those features by ourselves, right? It's a lot of work. And you should provide captions for media. For example, for videos, you should provide subtitles. For images, you should provide alt tag or accessibility label. to say what that image is, right? Otherwise, a blind person cannot know what is there. If your app is built for web, you should also make it work with a keyboard. Why? Because say you have mobility impairments, you cannot move your hands. So some people, they wear some kind of cap, and there will be one rod coming from the cap which will interact with the keyboard. And since they cannot move their hands, that's the only way they can interact. So it's important to make this work with the keyboard so they can navigate your site. And the last thing is, we should also make sure the contrast is correct, which Ankita already talked about, and make sure the colors are OK for color blindness. OK, so talking about inclusiveness, those are not the only thing. There is also right-to-left languages. What are right-to-left languages? They are known by RTL or short. You might have heard about RTL. When we write English, Polish, these languages, we write from left to right and read from left to right. But there are RTL languages, like many Arabic languages, which are read from right to left. So in those languages, books open the other way. They don't open like, they open like this. In our case, they open like this. So a lot of UI elements are also flipped in this case. Here is a screenshot from Android settings. You can see there is English, and here is some Arabic script. The UI elements are flipped. The icons are on the right. The text is aligned to the right. But you can also see that this text is not flipped. So you have to be careful what you flip. Most of the time, React Native takes care of it by default. When you use Flexbox, it automatically changes the how it flips, how the content flips. But sometimes you have to be careful. There is some APIs in React Native which you can use. There is I18N Manager, Force RTL. That forces your app to be in RTL mode, so you can see how it looks in RTL mode. You have to restart the app after enabling this. Then there is I18N Manager is RTL. So this is a Boolean which tells you if you're in RTL mode. You can use this API to check and rearrange your UI elements. OK, linking, everyone's favorite. So linking, if you're building a React Native library, you must have heard about linking. To use your native library, people have to run React Native link library name, right? And I see a lot of libraries do not work with link. And it's very annoying to work with because now you have to edit the native files and change things. So if you're working on a library, make sure that it works with link. But very soon, these awesome people are working on a new way to link libraries. So you just install a library, and it is linked automatically. You don't have to do any extra work. So look forward to that. Documentation, next thing. Documentation is probably the most important part of a component library. If you have good documentation, you have happy users. But writing and maintaining documentation can be a lot of work. So I love to automate things. I love to automate things which can be automated. And documentation is one thing which can be generated from your code. I agree that a lot of generated documentation is bad. But I think it's not because generation of documentation is bad. It's because they're generated, nobody cares about them. You also need to care. You also need to write detailed comments. You need to write examples. So there are a lot of tools to help you with that. For example, in React components, you can write comments on your props. You can write comments describing your component. And React docgen library can extract all of the documentation from the code. You can also write documentation separate files, like we do in paper. We also have code comments. So we use a hybrid approach. We have code comments plus markdown files. And there are some tools to help. This is how it looks when you have a prop type and you have a comment. This is TypeScript. You can also have something similar in Flow. It also works with prop types, but prop types is less precise, so I prefer to use TypeScript. So there is this tool called docz. This automatically handles all this. We also have our own tool in Callstack, component docs. It also handles all of these. But if you don't want this auto generation and you want only markdown files, you can use Dokusaurus. It is a tool made by Facebook to write documentation. And when you have a library, you also want to provide examples. You can use a snack to provide runnable code. So in your documentation, you can have one example which user can change and see what is changing live. There is also React Live and React Native Web Player, which have the same functionality. In React Native Paper, we have a link below every code snippet. You can click it to open a full editor, which you can run on your device. OK, next, static types. So how many of you use static types, like Flow or TypeScript? Oh, very few people. More people should use it. This is my feeling when I see people who don't use static types. It's awesome, because when you have static types, you get autocomplete, you get error checking. The development experience is a lot better, and is especially good for libraries, because somebody else wrote that library, and now you're using it. You just type, and you have autocomplete for all of the APIs. You don't even have to read the documentation. And also, if you have comments above your props, TypeScript will also show you what it says. So there is no reason to go to the documentation website if you have types. So there are two tools for types, Flow and TypeScript. I will quickly compare those and tell you which one I prefer for libraries. So Flow, it has breaking changes in each release. It is very much tied to React Native versions. There is no good workflow for libraries. I like Flow, and it's very good for apps. But I think it's not a good fit for libraries, because it keeps changing, and you have to keep updated with the versions. You have to change your library, and it's very flaky. Whereas TypeScript is stable, there are very few breaking changes. There are good workflow for libraries, like the CLI. It can extract definitions. And even if the user does not use TypeScript, IDE like VS Code can see the definition in your code and provide autocompletion. So it's always good, right? So code quality, what's the most important part in our code? Semicolons or not? No? OK, so it's tabs or spaces. OK, just kidding aside, there was this TV show, Silicon Valley. They broke up because of tabs with spaces. Yeah, so anyways, there are tools like ESLint and Prettier, which help you to enforce some code styling guides. There is Jest and Detox for integration tests, and React Native testing library by Callstack for unit tests. I also like to use Husky. What it does is it allows you to run a pre-commit hook. So before you commit, it can check your code for any lint errors, or any errors in unit test, whatever you want, then you don't have to wait for the CI to pass when you're committing. I also use commit lint. It lints your commit message. I like to format my commit messages because then I can automatically generate a change log from them. So that's one thing I like to do. And then I run all of these tests on Circle CI. It's a great feeling to see all these green check marks. OK, so next one is publishing. You wrote this amazing library. Now you want to publish it. So publishing can be tricky. There is a lot of things you need to handle. First of all, what to publish? Like you have source code, and you have README files, you have tests, you have fixtures. You cannot publish all of them because the size of the library will be much bigger. So what I publish is the source code for Metro, because Metro bundler in React Native can handle source code. Then if it supports web, I also publish a ES modules build, which is import and export, and common JS build for everything else. For example, Jest or Node server-side rendering, or any bundler which does not support import-export. And if you're using a type checker like TypeScript or Flow, you also want to ship definition files. Then you can specify all of the entry points in your package.json. Like you have a main field, which will be the common JS build. You have a module field, which will be the ES modules field. You have a React Native key, which will be the source. And you also have a types for TypeScript types. And you can use the files field in package.json to say that I want to ship these folders. Because there are two ways. There is npm ignore, where you can mention these files I don't want to ship. Or you can use files field, where you say I want to ship these files. The difference is when you say I want to ignore these files, in future you add something which is not supposed to be shipped, but now it is getting uploaded because you forgot to add it to ignore, right? So it's better to use files field, in my opinion, and that's what I have been using. So as you can see, lots of things to keep track of. We recently published this CLI, React Native Communities /Bob, Bob the Builder. You can you can build files for all of the targets, like CommonJS, ES modules, types. All you have to do is run Bob in it once after installing it, and it will configure your project, configure your library to do everything. This is in action. You just run Bob in it. Now it asks you some questions, like where is your source file, where is your destination file, and what builds you want. Then, quick. OK, so it configures the project. Now when you run npm publish, it will run yarn prepare or npm prepare, whatever you use. And it will build everything automatically, so you don't have to worry about anything. So if you're building a library, give it a try and let me know if you have any issues. Another tool I like to use is release it. Because when you're publishing a library, there is a lot of things you need to take care of. You need to tag a release. You have to create a release on GitHub. You have to write release notes. Then you have to run npm publish. Right? So release it does everything automatically. You just run release it, and it will automatically generate a change log from your commit messages. It will create a tag, create a release on GitHub, increment the version according to the same ver, and publish to npm. You can also use it on the CI to automate all of these. I'm using it on GitHub Actions. It automatically publishes a new version when I push to master. You can also use semantic release, which is a very similar tool. OK, so before I finish, one last thing. If you're building a component library, keep it maintainable. It's very exhausting when you're building a component library. Everyone has their own feature requests. And the more features you add, the harder it becomes to maintain. Remember, it's easier to add a feature, but it's very difficult to remove it, because now there are people who are relying on the feature. You cannot just remove it, right? And one thing I have seen is a lot of people want to add a component in a library because they're using this library, and they don't want to write any custom component. They want to use everything from the library. I think it's not good, because a library cannot have everything. There are some components. If it is specific to your use case, you should write it. So that's one thing we should be more comfortable with. OK, so that's all from me. Thank you very much for having me. See you later.